Hello friends, in this video we are going to discuss the previous year GATE question number 90. This question is from GATE 2004 examination. Let us read the question. Figure shows a chopper operating from a 100 volt DC input. So VDC is 100 volt. The duty ratio of the main switch S is 0.8. D is equal to 0.8. The load is sufficiently inductive so that the load current is ripple free. Okay, the average current through the diode D under steady state is, okay, and they have given the four options. So if you check, it is a buck converter. Okay, so we are having it is a buck converter or step down chopper. Buck converter. If you recall the video sessions, in that we have derived the expression for the average value of the diode current. Yes, here Vs is equal to 100 volt, that is the supply voltage. D is equal to 0.8. Okay, and what is the ID? Yes, you can check the diode D will be in the on state only when the switch will be in the off state, right? Because when switch is in off state, at that time the inductor releases the energy, right? So from T on to T, yes, the current flowing through the diode, it will be like inductor current. So it will be changing from Imax to Imin. So it is the same as that of the IL. Okay. Further, we have yes redrawn this as equivalent to average value of the inductor current, right? We already discussed this in the video sessions. What about this magnitude? This magnitude is like a IL average, which is equal to I0 average. Is equal to I0 average. Okay, this is a T on, that is a dt, and this is the total time T. Okay, so therefore if you check, yes, from the given data we can write D is 0.8, Vs is 100 volt. So therefore what is the V0? V0 is equal to D into Vs, is equal to 0.8 into 100, so is equal to 80 volt. Okay, now V0 is 80, so what about the I0? It is a V0 by R. So it is equal to 80 divided by R. R is 10 ohm. So it is equal to 80 by 10. So it is equal to 8 ampere. Okay. So I0 is 8 ampere. Okay. Now what is the ID? We can write ID average. They have asked for the ID average. Average value of diode current. So it is a 1 by T integration from T on to T. That is a dt to T. Okay. It is a I0 average. That is I0 into dt. So further we can simplify it as is equal to I0 by T, because I0 is constant current, so we can take it outside. So I0 by T into, yes, we can take the integration, and if we put the limit, it will be like T minus dt. Okay, so if you take the T common, it will be cancel out. So it is a 1 minus D into I0. So now from this we can write it is equal to 1 minus D is 0.8 into I0. I0 is 8 ampere. Okay, so 0.1 minus 0.8 into 8 ampere, so it is like a 0.2 into 8, so it is a 1.6 ampere. This is what the average value of the diode current, that is the ID average, will be having. Okay, so ID average is equal to 1.6 ampere, is equal to 1.6 ampere. Okay, so if you check the options, correct option is option A. Okay, so this is about question number 90. In the next video, we are going to discuss the question number 91. Thank you.